The sum of the first 10 terms of an arithmetic sequence is 190.
Fat Math, the right path to develop the fat brain that you've got. Hello everyone and welcome to Fat Math TV.
In this video, you will learn how to answer more items on some of the terms of an arithmetic sequence. Number 1. Find the sum of the integers from 1 to 40. So the integers would be 1, 2, 3, 4, 5, 6, and so on up to 40. What is the sum of these terms? So here, our a sub 1 is 1. That's the first term. The common difference is 1. That is obtained by subtracting 1 from 2 or 2 from 3. Or that 2 times 1 or 3 minus 2, that's 1. And the sum of the first 40 terms or integers from 1 to 40, there are 40 of them. Okay, so we will be using the formula S sub n equals n over 2 times a sub 1 plus a sub n. So our n here is 40. So 40 divided by 2 plus or times a sub 1 is 1. And a sub n, that's the nth term or the 40th term, that is 40. And then 40 divided by 2 is 20. 1 plus 40 is 41, and 20 times 41 is 820. So that is the sum of the integers from 1 to 40, 820. So here we just use the formula S sub n equals n over 2 times a sub 1 plus a sub n. Number 2. Find the sum of the odd integers from 1 to 50. So what are the odd integers from 1 to 50? So they are 1, 3, 5, 7, and so on up to 49. So the first term is 1. The common difference is 2. That is 3 minus 1. Or it can also be 5 minus 3. And a sub n is 49. So that's the last term. The nth term is 49. Okay, so for our formula for the nth term, a sub n equals a sub 1 plus n minus 1 times d, because we want to know which term is this 49 is. Is it the 49th term or 50th term or just the 25th term or whatever? So we will identify n here so that we will know which term is 49. So a sub n is 49. So replace that there, equals a sub 1 is 1 here. And then n minus 1 copy, and the common difference is 2. It's here. And then add negative 1 to both sides of the equation. You will get 48 here equals, this one will be 0. N minus 1 times 2. So divide both sides by 2. 48 divided by 2, you will get 24. So you'll be left with n minus 1 here on the right side. And since there's a minus 1 here, add 1 to both sides of the equation. You will get 25 equals n. So this 49 is the 25th term. So we will use again the formula S sub n equals n over 2 times a sub 1 plus a sub n. So n is 25 over 2 times a sub 1 is 1, and the nth term a sub n is 49. 49 times or plus 1 is 50, and then 50 divided by 2 is going to be 25. So we can cancel here 2 and 2. This is going to be 25. So 25 times 25 is 625. So the sum of the odd terms from 1 to 50 is 625. Number 3. Find the sum of the even integers between 11 and 95. So it's only the even integers. So we have the first integer between 11 and 95 is 12. What's the next even integer? 14, and then 16, and so on up to the last term is 94, since they are even integers. So the last term is 94. So what is the sum of this? 12 plus 14 plus 16 plus and so on up to 94. So we will use the same process. A sub 1 here is 12. That's the first term. Common difference is 2. That's 14 minus 12 or 16 minus 14. A sub n, or the nth term, is 94. We need to identify which term is this 94 so that we will know n. So we will use this formula. A sub n equals a sub 1 plus n minus 1 times d. A sub n is 94. Replace that there. A sub 1 is 12. Copy n minus 1. D is 2. Add negative 12 to both sides of the equation. You will get 82 here. And then copy n minus 1 times 2. And then divide both sides by 2. 82 divided by 2, you will get 41. And then add 1 to both sides of the equation. 41 plus 1 is 42. Meaning to say, this 94 is the 42nd term. There are 42 even integers between 11 and 95. So for the sum, we will have S sub n equals n over 2 times a sub 1 plus a sub n. N is 42, so 42 divided by 2 times a sub 1 is 12 plus a sub n is 94. 42 divided by 2 is 21. 12 plus 94 is 106. And 21 times 106 is 2,226. So the sum of the even integers between 11 and 95 is 2,226. Number 4. Find the sum of the multiples of 3 from 33 to 63. So what are the multiples of 3 from 33 to 63? Of course, we shall start with 33. And what's the next multiple of 3? 36 and 39 and so on. When you say multiple of 3, these are numbers that if you divide by 3, the remainder is 0. Okay, so 33, the second will be 36, the third will be 39, and the last will be 63. So we will do the same process. Identify which term is 63. Is it the what is n? So we will use the formula a sub n equals a sub 1 plus n minus 1 times d. So for this sum, the first term is 33. The common difference is 3. That is 36 minus 33 or 39 minus 36. And the nth term is 63. So let's solve for n. A sub n here is 63. A sub 1 is 33. Copy n minus 1. And common difference d is 3. Add negative 33 to both sides of the equation. You will get here 30 equals n minus 1 times 3. Divide both sides by 3. You will get 30 divided by 3. It's 10. And then add 1 to both sides of the equation. 10 plus 1 is 11. So this 63 is the 11th term. So there are 11 multiples of 3 from 33 to 63. So let us now use the other formula for the sum. S sub n equals n over 2 times a sub 1 plus a sub n. N is 11, so you will have 11 over 2. A sub 1 is 33, and a sub n is 63. 33 plus 63 is 96. And then you can divide or cancel here 2. Divide this by 2. This is 1. Divide this by 2. That's going to be 48. And 11 times 48 will be 528. So the sum of the multiples of 3 from 33 to 63 is 528. So in this lesson, you should be able to identify the first term, the common difference, and n before you can use the formula for the sum of the first n terms. Number 5. Find the sum of the numbers between 10 and 200 which are divisible by 9. So the first step here is to identify the numbers. What are the numbers that are divisible by 9 between 10 and 200. What is the lowest or the least? It must be 18. And the highest, you should also identify, that's 198. So 18 will be the first, and then 27, and then 36, followed by 45, and so on. But how will you identify 198? You can just do this by trial and error. You can divide 200 by 9 and identify the remainder. So the remainder is 2, so you just subtract 2 from 200. That's going to be 198. Or you can apply what you learned in elementary of the number theory, that the sum of the digits, if the sum of the digits is divisible by 9, then the number is divisible by 9. And the highest of them is, for those less than 200, is 198. If you add 1, 9, and 8, that's 18. Since 18 is divisible by 9, therefore 198 is divisible by 9. So here, the first term is 18, the common difference is 9, and the nth term is 198. Let's identify how many terms there are. Let's use a sub n equals a sub 1 plus n minus 1 times d. A sub n is 198, a sub 1 is 18, copy n minus 1, d is 9. And then add negative 18 to both sides of the equation. You will get 198 minus 18 is 180. Copy n minus 1 times 9. Divide both sides by 9. 180 divided by 9, that is 20. And we will be left with n minus 1 on the right side of the equation. And then add 1 to both sides of the equation. N is equal to 21. So there are 21 multiples of 9 between 10 and 200. Okay, let's identify the sum. So S sub n is equal to n over 2 times a sub 1 plus a sub n. N is 21, so 21 over 2 times a sub 1 is 18, and a sub n is 198. 18 plus 198 is 216. 216 divided by 2 times 21 is 2,268. You can cancel this. You will have 108. And 21 times 108 is 2,268. So the sum of the numbers between 10 and 200, which are divisible by 9, is 2,268. Number 6. The sum of the first 10 terms of an arithmetic sequence is 190. What is the first term if the last term is 46? What is the common difference? So the sum of the first 10 terms is 190, meaning to say S sub 10 is 190. The last term, A sub 10, is 46. What is the first terms? So A sub 1 is unknown. Since there are 10 terms, our N here is 10. And for letter B, what is the common difference? So D is also unknown. So here our N is 10 because there are 10 terms. So N equals 10. So let's use this formula. S sub N is 190. Okay, so 10 over 2 times. Okay. S sub 10 is 190. N is 10, so that's 10 over 2. It's 5. And then A sub 1 is unknown, and A sub 10 is 46. Okay, so this is again a linear equation. Divide both sides by 5. 190 divided by 5, that is 38. And then add negative 46 to both sides of the equation. 38 minus 46 is negative 8. So the first term is negative 8. And then for the common difference, let us use this formula for the nth term, A sub n. equals a sub 1 plus n minus 1 times d. A sub n is 46. That's a sub 10 equals a sub 1 plus 10 minus 1 times d. A sub 10 is 46. A sub 1 is what we have obtained here in the first part of the process is negative 8 plus 10 minus 9 is 10 minus 1 is 9, 9d. And then how do we solve this linear equation? Add 8 to both sides of the equation. 46 plus 8, that is 54. So 54 is equal to 9d. Divide both sides by 9. 54 divided by 9 is 6. So the common difference is 6. So the first term is negative 8 and the common difference is 6. Number 7. The sum of the first 20 terms of an arithmetic sequence is 2,110. What is the first term if the last term is 1, and what is the common difference? So same kind of problem. So we will have also the same process. So there are 20 terms and the sum of the first 20 terms is 2,110. So n here is 20. So n equals 20. And then the first term is unknown. The 20th term or the last term is 1. So a sub 20 is 1. What is a sub 1, or what is the first term, and what is the common difference? So we will use this formula. S sub n equals n over 2 times a sub 1 plus a sub n. So we will have S sub 20 equals 20 over 2 times a sub 1 plus a sub 20. S sub 20 is 2,110. 20 over 2 is 10. Copy a sub 1, and a sub 20 is positive 1. Divide both sides by 10, you will get 211. Add negative 1, you will get 210. So the first term is 210. For the common difference, we will use a sub n equals a sub 1 plus n minus 1 times d, the formula for the nth term of the sequence. Okay, so a sub 20 is equal to a sub 1 plus 20 minus 1 times d. A sub 20 is 1. A sub 1 is 210. 20 minus 1 is 19. Add negative 210 to both sides of the equation. 1 minus 210 is negative 209. Divide both sides by 19, you will get negative 11. So the common difference is negative 11. So a sub 1 is 210, d is negative 11. Number 8. The second term of an arithmetic sequence is negative 7. Its eighth term is 11. Find the sum of the first 10 terms. So a sub 2 is negative 7 since the second term is negative 7. Eighth term is 11, so a sub 8 equals 11. What is s sub 10? Because find the sum of the first 10 terms. So what are we going to do? Take note that we add the common difference to a sub 2 to get a sub 8 6 times. So the difference of a sub 8 and a sub 2 is 6d, or that is 11 minus negative 7. Okay? 6d equals 11 minus 7, because the difference of the eighth term and the second term is 6d. There are, you added the common difference 6 times. A sub 2 is a sub 1 plus d. A sub 8 is a sub 1 plus 7d. So if you subtract that, the a sub 1 will be cancelled. That's going to be 0. And then 7d minus d is 6d. That's why 6d is equal to the difference 11 minus negative 7. 11 minus negative 7 is positive 18. Divide both sides by 6. You will get d equals 3. So a sub 2 is a sub 1 plus d. Here we will solve for a sub 1. You can also use the formula for a sub 8. So if that's the case, we will have a sub 2 is negative 7. That's given. A sub 1 is unknown. And the common difference that we got here is 3. And then add negative 3 to both sides of the equation, you will get negative 10. But if you use the formula for a sub 8, you will get the same answer, that a sub 8 is equal to a sub 1 plus n minus 1. That's 8 minus 1. That's 7 times d. So a sub 8 is 11. That's given. A sub 1 is what we're looking for. Plus 7 times d. D is 3. So 7 times 3 is 21. And then a sub 1 is going to be 11 minus 21. Still negative 10. So if you use this process for a sub 1, it's fine. If you use this one, still okay. Because we need that a sub 1 to solve for the sum. Here, we need a sub 1 and the d. That's why we solved for d here at the first, and then a sub 1. Okay, so s sub 10, since the sum of the first 10 terms is 10 over 2, that's n over 2 times 2 times a sub 1 is negative 10 plus 10 minus 1, this is n minus 1 times d. So 10 over 2 is 5. 2 times negative 10 is negative 20. 10 minus 1 is 9. 9 times 3 is 27. Negative 20 plus 27 is 7. 5 times 7 is 35. So the sum of the first 10 terms, if the second term is negative 7 and the eighth term is 11, is 35. So in this kind of item, first, what you're going to do is solve for the common difference. How do you do that? You just explore these, what do you call this, values of a sub 2 and a sub 8. Since the difference is 18, that is also 6 times the difference, because you need to add the difference to a sub 2 6 times to get the eighth term. Let us have a similar example. The fourth term of an arithmetic sequence is 14. Its ninth term is 34. Find the sum of the first 12 terms. So a sub 4 is 14, a sub 9 is 34. So the difference of 34 and 14, which is 20, is how many times the common difference? From a sub 4 to a sub 9, how many times will you add the common difference? 5 times. That is just 9 minus 4. So 5 times the difference is equal to the difference, which is 20. Okay, so 5d is equal to 20 and d is equal to 4. And then before we solve for s sub 12, we need to identify a sub 1 first. That is by using the formula for a sub 4. A sub 4, this is a sub n equals a sub 1 plus n minus 1 times d. A sub 4 is a sub 1 plus 3d. A sub 4 is 14. D is 4 that we got here. So 3 times 4 is 12. 14 minus 12 is 2. So a sub 1 is 2. If you use the formula for a sub 9, a sub 9 is equal to a sub 1 plus n minus 1 is 8d. And then a sub 9 is 34 equals a sub 1 plus 8 times d is 4. So that's 32. So 34 minus 32 is still 2. And then we can already use the formula for the sum of the first n terms. S sub n equals n over 2 times 2a sub 1 plus n minus 1 times d. So n is 12. So 12 over 2 times a sub 1 is 2 plus n minus 1 is 12 minus 1, d is 4. 12 divided by 2 is 6. 2 times 2 is 4. 12 minus 1 is 11. 11 times 4 is 44. 4 plus 44 is 48. 6 times 48 is 288. So the sum of the first 12 terms of the sequence with fourth term a sub 4, with fourth term 14 and ninth term 34 is 288. Number 10. Find the sum of the first 10 terms of an arithmetic sequence whose general term is 4n minus 9. So we need to identify the terms. So a sub 1 is, that is, you use n equals 1. So for a sub 1, that's 4 times 1 minus 9. 4 times 1 is 4. 4 minus 9 is negative 5. A sub 2 is 4 times 2 minus 9 equals 8 minus 9, that is negative 1. A sub 3 is 4 times 3 minus 9, that is 3. So therefore, as what you can see here, the common difference is 4. Negative 1 minus negative 5, that's positive 4. Or 3 minus negative 1 is also positive 4. So D is 4 because we need D for the sum of the first n terms. So S sub n is n over 2 times 2a sub 1 plus n minus 1 times d. Our n here is 10 since the sum of the first 10 terms. So 10 over 2 times 2 times a sub 1 is here, negative 5, plus n is 10 minus 1 times d is 4. 10 divided by 2 is 5. 2 times negative 5 is negative 10. 10 minus 1 is 9. 9 times 4 is 36. Negative 10 plus 36 is 26. 5 times 26 is 130. So the sum of the first 10 terms of an arithmetic sequence whose general term is 4n minus 9 is 130. So we needed to identify here the first few terms so that we will know the common difference. Or it's enough if you only have a sub 1 and a sub 2. Negative 1 minus negative 5 is already positive 4. And then use the formula for the sum of the first n terms. That's it for our examples. Here are items for practice, or this can also be your quiz. We have here 8 items similar to the examples. Number 1, find the sum of the integers from 1 to 80. Number 2, find the sum of the odd integers from 1 to 90. Number 3, find the sum of the even integers between 4 and 100. Number 4, find the sum of the multiples of 7 from 35 to 91. Number 5, find the sum of the numbers between 20 and 200 which are divisible by 6. In number 5, you need to identify the first term and the last term. Number 6, the sum of the first 20 terms of an arithmetic sequence is 150. What is the first term if the last term is 55? What is the common difference? So this is also similar to our examples. Number 7, the fifth term of an arithmetic sequence is negative 11. Its seventh term is negative 29. Find the sum of the first 10 terms. And number 8, find the sum of the first 20 terms of an arithmetic sequence whose general term is given by 5 minus 2n. So all of the items here are similar to our examples. So if you can't answer these yet, you go back to our examples and pause the video for more time of answering. Thank you so much for supporting our channel. Please like and subscribe and share our channel to your classmates so that they will also learn, or they will also have a helping hand in studying mathematics. Let us check. Number 1, 3,240. Number 2, 2,025. Number 3, 2,548. Number 4, 567. Number 5, 3,330. Number 6, the first term is negative 40 and the common difference is 5. Number 7, negative 155. And lastly, number 8, it's negative 320. Thank you for watching. Comment, like, and subscribe. Bye!